Hi, this is Andrea Hendricks. The topic of this video lecture is how to convert between degree and radian measure. So let's review what we know. We know from the previous lesson that 360 degrees is equivalent to 2 pi radians. We also know that 180 degrees is equivalent to pi radians. So to find out what 1 degree is equivalent to, we can divide each side by 180 to get that 1 degree is really pi over 180 radians. Now, in a similar fashion, we can figure out what 1 radian is equal to. If we divide by pi, we get 1 is equal to 180 over pi degrees. So 1 degree is pi over 180 radians, and 1 radian is 180 over pi degrees. So to convert from degrees to radians, we're going to multiply the degrees that we're given by pi radians over 180 degrees. To go from radians to degrees, we're going to multiply by 180 degrees over pi radians. So think about it like this. Whatever you're trying to convert to is what's going to be in the numerator of the fraction. The denominator is the equivalent form. So if we're trying to go to radians, we know that pi radians is equal to 180 degrees, right? That's the equivalent form up here. Oops. Let's just take that off. Let me highlight that for you. Here, this is a key fact we're using. 180 degrees is pi radians. So the numerator and denominator are really a form of 1, okay? And so we're just trying to know what we're going to goes in the numerator, what we're coming from is what goes in the denominator. So let's take a look at some of these types of problems. Let's say we want to convert to radian measure. There's really 2 ways to do it. One way is to leave pi in your answer, and one way is to convert it to a decimal. So for the first 2 examples, let's leave pi in our answer, and the last 2 we'll write as a decimal. So if I want to go from 150 degrees to radians, I'm going to multiply 150 degrees times, I'm trying to go to radians, so I need my pi radians over the equivalent, which is 180 degrees. And then we can cancel out things that are common, right? There's a factor of 10, so those zeros will divide out. Also between 15 and 18, there's a factor of 3, right? So we can reduce that to really 5 pi over 6 radians. And again, you don't typically have to write the word radian there at all. What about negative 20 degrees? Well, there I would have to multiply negative 20 degrees by pi radians over 180 degrees. Well, there's a common factor of 20 that I can divide out, so that's going to leave me with a negative pi over 9 radians. Now for the last 2, let's convert that to a decimal form of the radians. So if I wanted to go from 115 degrees to radians, I'm going to have to multiply 115 degrees times pi over 180. And I've done that on the calculator, so let me just show you that. So 115 times pi over 180. To get the pi, you have to use the second and the caret symbol. There's a pi symbol in blue. So 115 times pi over 180 gives us 2.007. Now, in a likewise fashion, we can go from negative 46.52 degrees by multiplying by pi over 180 to get to radians. And I've done that already on the calculator as well. Negative 46.52 times pi over 180, if we round to 3 decimal places, would be negative 0.812. Now, what about converting from radians to degrees? So here I would have to multiply, if I have negative 7 pi over 6, we would have to multiply that by I'm going to degrees, so I need 180 degrees over the equivalent, which is pi radians. So we notice that the pi's are going to divide out. 6 goes into 180 30 times, and then 30 times the negative 7 would be negative 210 degrees. To convert 3 pi radians to degrees, I'm going to multiply by 180 over pi. So my pi's divide out. 3 times 180 would be 540 degrees. Now for the last two, let's convert this to decimal form, but it's going to be the same principle. I'm going to still multiply by 180 degrees over pi radians, and my pi's are going to divide out, so I really have 180 divided by 7, which is 25.714. Okay, and what is that in? That's in terms of degrees. Now you can't leave off the degree symbol, right? That has a distinctly different meaning than just the 25.714. 25.714 without a symbol would mean radians, and we don't want to do that there. Now to do negative 2 to degree measure, I'm going to multiply by 180 over pi, and I'm going to have to use a calculator here. So I would have negative 2 times 180 divided by my pi. And that's going to give me negative 114.592. And again, in terms of degrees. Okay? Now, I want to leave you with 3 charts. I don't know if you've seen this before. This is called the unit circle, and it's going to be very important in our study of the next few sections that we're going to talk about. The unit circle is a circle whose radius is 1 unit. Okay? And it's divided up with some angles already here. We have a 30-degree angle, 45-degree angle, 60-degree angle, 90, and so on. You don't need to worry so much about the positive and negative stuff. That's going to come up later on in another section. But right now, you should be able to recognize these angles. You should know these pretty well and how they're placed on the unit circle. So if I said to draw me a 270-degree angle, you should know that that's going to be an angle that's 3/4 of the way around the circle. Or if I said draw me a 150-degree angle, you should know that that angle is going to lie in, or its terminal side will lie in quadrant 2. Okay? So very important to be able to know this. Now the other thing that I have is a picture of the same unit circle, but this time in terms of radians. Very, very critical that you identify the relationship between the degrees and radians on the unit circle. So you should know pretty well that pi over 6 is the same thing as a 30-degree angle. Pi over 4 is a 45-degree angle. Pi over 3 is a 60-degree angle. So in fact, you may even want to take this chart and put beside it the equivalent angle in terms of degrees. I've given you another copy of this, a blank copy. Print this as many times as you want and use it to practice identifying the way that these angles are defined on the unit circle. Okay, so really become familiar with the unit circle in terms of degrees and those common angles in terms of radians. So if you have any questions about how to convert from degrees to radians or vice versa, please contact me.